SQL also includes several aggregate functions such as min, max, average, sum. To play with these, we're going to switch over to tempdb and generate some sample data. So this will create the raw data table and put some data into it, which will work well for the aggregate functions and crosstab queries and things I'm going to show you in a few minutes. Okay, the basic aggregate functions. There's count, sum, average, min, max. And they do exactly what you would expect them to do, for the most part. The key thing to notice here is that the result was only a single row. Look down at the result row. It ended up taking the entire raw data table and giving us one row with the count, the sum, the average, the min, and the max. Looking at the logical flow of the query, the summing function here was placed after the columns and expressions, so we had a full complete data set. The where clause, if there was one, would have restricted the rows. We calculate any columns or expressions we want, and then those are summed, and it produces a single row result. And that's how the aggregation works in the logical flow. Something to be aware of is that the average ignores or skips over any nulls as it averages it out. It's not good or bad. It's not a moral decision. It simply skips it over. So you need to be aware of this as you're calculating your averages. So the next query illustrates that, as well as how implicit conversions work for data types. So when we're averaging the amount is an integer and there are a few nulls in the table. If we cast that amount as a numeric prior to averaging it, it'll be able to average it as a numeric with 9 characters total, 5 to the left of the decimal place. So the first column average will give us more precision than will the second column, which has to stay as an integer. And both of these averages will ignore nulls. The third column is going to sum the total amount and then look at the total number of rows to calculate a manual average. So this column will include nulls in the count. And if we execute this, you'll see the difference dramatically. The first one gives us more precision at 47.3. The second one is just an integer amount. And if we include those additional rows that have nulls, the average drops down to 39. So you need to be aware of how nulls affect averages when you're performing aggregate functions. There are also a few statistical functions, not a ton of them, and if you need to do some serious statistics, I would recommend exporting the data into Excel and using Excel because that has a fantastic full set of statistical functions. But SQL Server does include standard deviation and variance designed both for a full population or for a subpopulation. So if you're working with a full population, you use standard dev p or variance p. And if you're working with a subpopulation, just use the standard deviation or the variance. And all of those functions work by summing a full data set into a single row.